Let's find the inverse derivative of a function followed by the second implicit derivative of an equation. So we'll start with the function f of x equals x squared plus 1, where x is greater than or equal to 0. Let's find the inverse. So we'll set y equals x squared plus 1 and solve for x. So x squared equals y minus 1, which implies that x equals the square root of y minus 1. So that tells us that f inverse of x equals the square root of x minus 1. Now let's find the derivative. So f prime of x equals, that's just 2x. Okay, so recall the formula for the inverse derivative. So f inverse prime of x equals 1 over f prime of f inverse of x. There we go. Now we just plug stuff in. So f inverse prime of x equals 1 over, what's f prime? 2x. So 2, and then what's f inverse? Square root of x minus 1. So that is the inverse derivative of that function. Okay, so now let's look at a similar expression, x equals y squared plus 1, and let's find the second implicit derivative of that. So we'll take d dx of both sides of the equation. d dx of y squared plus 1. Left-hand side is just 1. Right-hand side is 2y times y prime. We have to use the chain rule since we're differentiating with respect to x, and the variable is y. Okay, let's solve for y prime. So y prime equals 1 over 2y, which also equals 2y to the negative 1 power. There we go. Let's find y double prime. So y double prime, we take d dx of both sides of the equation again. d dx of y prime equals d dx of 2y to the negative 1 power. Okay, now what does that equal? We just use the power rule, bring down the negative 1, 2y to the negative 2, and chain rule again, so that's y prime. Okay, let's just rearrange that. So that's negative 1 over 2y squared times y prime. And what is y prime? Well, y prime is right there. So that equals negative 1 over 4y cubed. Okay, so we just found the inverse derivative of a function and the second implicit derivative of an expression. Hope that helps. Thanks for watching.